Hello everyone, I am Ajay Kumar M, Assistant Professor in the Department of Mathematics. In the today's session, now I am going to discuss the topic, the subject name, the calculus and linear algebra, the subject code, the 18 BMATC101. Okay, in that the module 5 linear algebra concept. Okay, now before going to the linear algebra concept, first the applications of the linear algebra in such a way that the number of applications in the fields of, especially in the computational vision, cryptography, optimization, image processing, and also many more applications, especially from the topic of linear algebra here. Okay, here in the today's class, now I am going to discuss the particular topic in the linear algebra, the rank of a matrix here. Okay, now before going to the rank of a matrix, okay, now first you have to understand the echelon form of a matrix. Okay, the another name we can call in terms of the row reduced to echelon form here. Okay, already all of you familiar with the in up to the PU level, okay, the matrix representation, okay, some of the operations of matrix here. Okay, here directly starting with the concept of the rank of matrix. Okay, before going to the rank of the matrix, first you have to understand the echelon form of a matrix. Okay, another name row reduced to echelon form here. Okay, now the first A be the matrix. Now which satisfies the following the properties here. Now we can consider in terms of the first one, the leading entry of a non-zero row should be 1 here. Okay, now we consider in such a way that the leading entry of the non-zero row should be 1. Now the second point, all the column elements below the leading entry 1 must be 0 here. Okay, all the column elements below the leading entry 1 must be 0. Now another one, if any 0 rows, it should come below all non-zero rows here. Okay, now we can starting with one example. Now we can consider in terms of, now we can specify in terms of, okay, for example here matrix A available, okay, the 1 2 3 4 0 1 2 3, another one 0 0 1 2, okay, the last row all the elements are 0 here. Okay, now we can consider in such a way that for the echelon form of a matrix, okay, the first point, the leading entry of a non-zero row should be 1. Okay, the leading entry now we can consider in terms of, okay, the 1 be the leading entry. Okay, now the next one, all the column elements below the leading entry 1 must be 0 here. Okay, all the column elements means here, okay, here leading entry, now the here column elements, okay, the below the leading entry must be 0 here. Okay, all the elements are 0 here. Now the next one is, okay, now another one leading entry, now we can consider in terms of all the elements are 0 here, now we can consider in terms of. Now the next one, the another one, the leading entry, now we can consider. Now the next one 0. Okay, the next another one point, if any 0 rows, it should come below all non-zero rows here. Okay, now what about here is, okay, particularly the matrix A consists of one particular row, all the elements are 0 here. Okay, all the elements are 0 means here, now we can consider in terms of, okay, now if any 0 rows available, it should come below all the non-zero rows here. Okay, here 3 non-zero rows available. Now the last, now we can specify in terms of, okay, now the matrix A now is in the form of echelon form here. Okay, is it clear all of you? Now in such a way that, especially from the module 5, the linear algebra topic, okay, the first we can discuss in terms of the rank of a matrix. Okay, before going to the rank of a matrix, okay, the 3 important observations. Okay, echelon form of a matrix, otherwise row reduced to echelon form here. Okay, in the syllabus point of view, the particularly restricted to the row operations here. Okay, that's why here we can discuss in terms of the row operations. Okay, from the topic linear algebra here. Okay, the 3 important points. Using these 3 points, now we can specify in terms of echelon form of a matrix here. Okay, now that will be the important thing here. Next we can discuss the rank of a matrix, the concept. Okay, now the number of non-zero rows in a row reduced to echelon form is called the rank of a matrix. Okay, already all of you know the echelon form, how to specify here. Okay, now with the help of the echelon form, next we can represent in terms of the rank of a matrix, the number of the important non-zero rows. Okay, now in a row reduced to echelon form is called the rank of a matrix here. Okay, now it is denoted by now the symbolic form, the row of A, otherwise we can call in terms of R of A here. Okay, now the example here is the first one, the matrix A here, the available here. Okay, the first, okay, now first you have to check for the whether it is an the given matrix is in the form of the echelon form here. Okay, now first check, okay, the leading entry 1, the first point, all the column elements below the leading entry are 0 here. Yes, now we can consider in terms of the leading entry, the all the column elements, the below the leading entry is 0. Okay, here also the leading entry is 0 here. Now the next one, the if any 0 rows available, okay, here no 0 rows available here. Now that's why here now we can consider in terms of is in the echelon form. Okay, the matrix A is in the echelon form. Now that's why here now we can specify in terms of the particularly the rank of a matrix A is equal to the 4 here. Okay, is it clear all of you? Okay, the important thing here, before going to represent the rank of a matrix, the first you can specify in such a way that the number of non-zero rows in a row reduced to echelon form. Okay, the important observation, after the row reduced to the echelon form, then only now we can specify in terms of the rank of a matrix here. Okay, now that will be the important observation. Okay, next we can consider the example sum, how to find out the rank of the particular matrix here. Next examples on the rank of a matrix, the first one. Okay, find the rank of the following. The matrix A is given, the first row elements 1, 1, 3, second row elements 1, 3, minus 3, 2, 4, 4. Okay, now the first observation, directly we can't specify the rank of the matrix unless the given matrix is in the form of row reduced echelon form here. Okay, now that's why here now we can consider in terms of the first, now we can specify in terms of, okay, here the matrix A is given as, okay, the next one, the operation, now we can apply the row transformations here. Now we can write on the symbolic form. Okay, now what about the next one, we can specify in terms of first check whether the given matrix A is already in the echelon form. Okay, the echelon form, the three important the properties, now we can consider in terms of the leading entry 1. Okay, now as the leading entry 1, now we can consider in terms of. Now what about the next one, the second point, all the column elements below the leading entry must be 0. Okay, now what about here is, here all the column elements here, the must be 0 means here other than 0 available, try to make in terms of the 0 form. Okay, now that will be the important thing here. Okay, now what about the next one, if any 0 rows available, no 0 rows available, okay, not required for the third point. Okay, now only we can concentrate for the first and second points here. Okay, now first represent in terms of echelon form, finally we can conclude that now the rank of the matrix here. Okay, now what about the next one, okay, the first row elements no changes, the same as it is, now we can specify. Now the next one, concentrate on second row elements here. Okay, now what about the second row elements here is, okay, now try to make that particular element 0, try to make the row 3, the first element, the 0 form here. Okay, now apply the transformation in such a way that R2 dash changes, right? Okay, now what about the next one, R2, okay, the same, the row 2 element, minus with the help of the first row element here. Okay, concentrate for the first element here. Okay, R1 now we can represent. Okay, because here one element available, how to make in terms of the particular one in terms of 0 with the help of the first row, first element 1 means here, okay, 1 minus 1, that's why here R2 minus R1, now we can easily specify here. Now what about the next one, second row operation, now R3 dash changes in terms of, okay, now what about the next we can specify in terms of R3 dash changes in terms of R3 minus, okay, here the element 2 here, how to make the element 2 in terms of 0 here S. Now with the help of the first row, first element here S twice the R1 now we can specify. Is it clear all of you? Now in such a way that S, the first we can apply these two row transformations. Now what about here? Obviously the row transformation first element along with another one, the element 0 here. Rest of the remaining elements apply the row transformation here. Okay, now the rest of the remaining elements we can apply the row transformation here S, okay, R2 minus R1, okay, here now we can represent 2. Now the next one S, R2 minus 3. Okay, now the next one we can specify in terms of minus 3 available here. Okay, S minus 6. Okay, minus 3 minus of minus 3 means here minus 6 now we can denote in terms of. Now the next one S. Okay, now the first element obviously is 0. Now what about the next one? Now we can consider in terms of R3, right, 4 minus 2 into the R1 element 1 here S. Okay, now we can denote in terms of the 2 here. Now the next one now we can specify in terms of the particularly we can denote. Okay, now the element here S R3 4 minus, okay, 2 into the R1 here. Okay, 2 into the R1 means here 4 minus 2 into the 3 here. Now we can consider in terms of 4 minus 6 here. Now we can consider in terms of minus 2 here. Okay, now next we can denote in terms of here S. Okay, now what about the next observation? Now we can specify in terms of matrix A. Now we can apply the transformation. That's why here symbol, right? Now next consideration. Okay, now what about your S? First row no changes. Okay, keeping the first row the common same. Now the next one we can denote in terms of, okay, now think all of you. Now the leading entry 1, all the column elements below the leading entry, now the 0 here available here. Now the next one, try to apply the transformation in such a way that S, try to make in terms of the corresponding the 2 in terms of the divided by 2 form. Now try to make in terms of the unit, now the 1 value. Okay, now we can apply the transformation. Otherwise directly we can also apply. Okay, which one is convenience? Now we can also specify here. Okay, now what about your S? R2 dash changes. Okay, right. Now we can consider in terms of 1 by 2 of R2. Now the next one R3 dash changes 1 by 2 of R3 here. Now what about the next observation here? S0 1, right? Okay, the minus 6 denominator 2 means here minus 3, right? Now the next one 0, okay, the denominator 2 here is 1 minus 1 here. Okay, now next observation. Okay, next one now we can denote in terms of apply the transformation, right? Okay, apply the transformation in such a way that the particularly now we can specify in terms of, right? Okay, now the corresponding, okay, now R3 dash changes in terms of, okay, now try to make that element the last row, the second element in terms of 0 form. Okay, how to make here is R3 dash R3 minus R2. Okay, using the row 2 element, now we can easily mention here. Okay, now what about here is first row element no changes, right? Next row element, now we can denote in terms of 0, 1, minus 3, right? Now the next one, the R3 minus R2 here. Okay, now 0 minus 0, okay, now we can specify in terms of 0 here. Okay, the one of the important observation, already the 0 available, try to represent in terms of the 0 form. Otherwise, once again the next simplification, too complex here. That's why here now we can represent in terms of here. Okay, now what about the next observation? S 1 minus 1, 0 here. Now the next one, now we can denote in terms of minus 1, minus of minus 3 here. Now we can specify here. Now we can denote in terms of the 2. Now we can denote. Okay, now the finally the another one transformation now we can apply S. Okay, 1, 1, 3, 0, 1, minus 3, 0, 0, 1 by applying the row transformation. R3 dash changes 1 by 2 of R3 here. Okay, now the final matrix check. now is in the echelon form here. Okay, echelon form means here leading entry 1, right? All the column elements below the leading entry 0, right? Next consideration. Okay, now the 0 here, next one 1 available. Okay, the last point not required. If any 0 rows available, okay, here no 0 rows available here. That's why here now we can conclude up to the here. Now we can find the rank of the matrix. Okay, the rank of the matrix row of A is nothing but how many non-zero rows available. Okay, first row, okay, one non-zero row, second row non-zero row. Okay, one of the important observation, if all the elements are 0, then only now we can call in terms of 0 rows. At least any one of the element, the non-zero form, now that one we can consider in terms of the non-zero row form here. Okay, now what about here is, now we can consider in terms of last row also, one element 1 available, that one also non-zero row. 3 non-zero rows available, that's why here now we can denote the rank of the matrix A is nothing but 3 here. Okay, now that will be the important thing. Is it clear? Now here, especially in the topic of the rank of a matrix, the examples in such a way that now these type of the particularly the matrices are given. Okay, the matrix are given. Now find the rank of the following here. Okay, we have to find out the rank of the matrix by applying the row transformation. That will be the important thing here. Okay, next example here. Second one, find the rank of the following. Okay, the matrix A is given. Okay, the first row elements, the second row elements, the third row elements, and also the fourth row elements here. Okay, now the next one, we can consider in terms of S. Okay, now okay, the first observation. Now we can specify in terms of the given matrix A is not in the echelon form. Okay, first you have to check whether is in the echelon form, is not in the echelon form. Okay, now that's why here now we can specify in the particular form, right? Okay, now first row elements no changes. Okay, keeping the first row element the same, now we can denote. Now apply the row transformation. Okay, now row transformation here S. Now the second row transformation R2 dash. Okay, the 2 available, try to make the 2 elements 0 means here R2 minus 2 into the R1. Okay, with the help of the first row first element, now multiplying 2 here, now we can easily make in terms of 0 here. Okay, remember the properly the how to apply the transformation form, the important here. Now the next one R3 dash S. Now we can denote in terms of R3 minus, okay, here 4 available, how to make in terms of the 0 here, the multiplying 4 into the R1 element here. Now the next one R4 dash, now we can specify in terms of R4 minus R1, now we can denote. Now with the help of these 3 transformation represent the element here. Okay, now the represent the elements here, now we can specify in terms of S. Okay, the first one 0, right? Now about the next one, now we can consider in terms of the 4 available. Now the 4 minus 2 into the, now the next one, now we can denote in terms of the particularly here 0, right? Now the next one, now we can specify in terms of 6. Okay, now the 2 into the minus 2 into the 4 here, now we can represent in terms of minus 2 here, right? Okay, now the next one 8 available, S 8 minus 2 into the R1. Okay, 2 into the R1 means here R1 3 available, 6 here. Now we can denote in terms of 8 minus 6, 2 now we can denote. Now likewise the next, the row 3 operations here. Okay, the first element now 0, 8, right? Minus 4 into the 2 here, so 8 minus 8 means here 0 now we can denote, right? Now the next one S R3 12, 12 minus, now we can denote in terms of the particularly 12 minus, wait, Okay, the row 3 elements here is now the row 3 elements here, the first 2 over R3, next one 12. Now we can consider in terms of 12 minus 4 into the R1. Okay, 12 minus 4 into the R1 means here, okay, the 4 available, 4 into the 4, 16. Okay, the 12 minus 16 now we can specify in terms of the minus 4 now we can denote. Now the next one we can denote in terms of S16, right? R3 element, okay, row 3 element here. Okay, 16 minus 4 into the, now what about here, next one, now we can denote in terms of 3 here, S. Okay, now what about the next observation, now we can specify in terms of, okay, 4 into the 3 here, 12, 16 minus 12, now we can represent in terms of the 4 here, now we can denote in terms of here. Okay, now the next one is R4 dash, R4, 1 minus 1, 0, right? Now the next one, 2 minus 2, 0, right? Now the next one, 3 minus 4 here, minus 1. Next, 4 minus 3 here, 1, now we can denote here. Okay, is it clear? The important observation, apply the properly the row transformation in such a way that with the help of the echelon form concept, that will be the important thing here. Okay, now the next observation. Okay, now the next one, the matrix A, now we can denote in terms of, right? Okay, now the leading entry 1 available, all the column elements below the leading entry is 0, the first one, okay. Next one here, 0 rows available, okay, 0 column available here. Okay, now the next one, now we can specify in terms of, okay, try to apply the transformation in such a way that R2 dash changes 1 by 2 of R2. Right, next one, R3 dash changes 1 by 4 of R4. Okay, now what about the changes here? Now we can specify 1, 2, 4, 3, right? Now the next elements here. Okay, now the corresponding, apply the transformation, minus 1, 1, right? Next elements here, minus 1, 1. Okay, the last row, the no transformation, that's why here the same elements. Now you can write. Okay, now the next observation is, okay, now we can apply the row transformation in such a way that the particularly first row no changes, keeping the second row also no changes. Now we can specify in terms of the same form, minus 1, 1 here. Now the next one, now we can consider in terms of as R3 dash. Okay, row 3 dash means here, now we can denote in terms of, okay, the particularly now we can specify in terms of row 3 dash, row 3 minus, okay, now we can specify in terms of row 2. Now the next one, R4 dash, now we can specify in terms of R4 minus R2 here. Okay, now the next one, minus 1, minus of minus 1 means here, now we can easily specify in terms of 0. Now here 1 minus 1 means here 0. Next we can specify 0. Okay, the two non-zero rows available here. Okay, the two non-zero rows here. Okay, the next one now we can specify in terms of the rank of a matrix A here. Okay, the rank of a matrix A means here, first we have to check for the row reduced echelon form. Now the first one S, now we can consider in terms of S. Okay, the leading entry 1, all the column elements below the leading entry is 0 here. Now we can specify in terms of, if any 0 rows available, it should come under the non-zero rows here. Okay, here two non-zero rows. Okay, the two zero rows available here. Okay, now for the rank of the matrix A, first we can specify in terms of how many non-zero rows available, first identify here. Okay, the totally the two non-zero rows available here. Now that's why here the rank of the matrix 2 here. Okay, is it clear all of you? Now the important observation, we have to find out the rank of the matrix in such a way that initially the given matrix is not in the echelon form. Try to represent in terms of echelon form. Later, now you can simplify the corresponding, apply the row transformation form. Finally, we can find out the rank of the matrix A here. Okay, the next example. Find the rank of the following. Okay, the matrix A is given. Okay, now we have to find out the rank of the matrix here. Okay, first observation is not in the echelon form. in case the given matrix is in the echelon form, directly we can say the rank of the matrix. But try to represent in terms of echelon form. Later, finally you can conclude the rank of the matrix series. Okay, now that will be the important thing here. Okay, now what about your S? The first one, now we can denote in terms of. Okay, here, now apply the row transformation here. Okay, keeping the first row elements, now we can represent in terms of the elements here. Now apply the rest of the remaining rows, the row transformation here. Okay, now S R2 dash, right? Now R2 minus R1. Now we can denote in terms of. Now S R3 dash, R3 minus R1. Now R4 dash, R4 minus R1. Now the next one we can specify in terms of R5 dash, R5 minus R1. Okay, apply the 4 row transformation. Now the elements now we can write down. Okay, now what about your S? The second row here 92 minus 91 1. Now the next one 93 minus 92 here, likewise 1. 94 minus 93 1. 1. Next element also 1 here. Now the next one R3 dash here. Okay, the R3 minus R1 here. Okay, 93 minus 91 2. 94 minus 92 2. Okay, likewise 95 minus 93 2. Okay, likewise similarly now we can denote the rest of the remaining elements here. Now the next one now we can specify in terms of, okay, R4 dash. Okay, now what about your S? Now we can specify in terms of the next R4 dash in such a way that R4 minus R1. Okay, row 4 elements 94 minus 91 3. 95 minus 92 3. Okay, now the next elements now we can denote in terms of. Likewise, the last row elements here, now R5 dash, R5 minus R1. Okay, now what about your S? Now we can denote in terms of the elements here, the particular form. Now we can specify here. Okay, now the next simplification. Now S, now we can apply the row transformation, the next particular form. Okay, now the thing all of you, now in such a way that the one unit element, the second row available, try to interchange these two rows. Now later we can apply the transformation, we can easily specify, we can easily find out the rank of the matrix series. Okay, now that will be the important thing here. Okay, now what about your S? Now we can apply the row transformation, R1, R2 row. Okay, the row 1 and row 2 interchange. Now we can consider in terms of, okay, after the interchange, now elements can be specified in terms of, now we can denote remaining elements, no changes, same as it is right down. Next transformation. Okay, now what about here? Keeping the first row elements the common, the same now we can specify. Now the next one, apply the row transformation, R2 dash. Okay, now what about the R2 dash means here? Next we can specify in terms of, okay, R2 dash here as R2 minus, okay, how to make the 91, the 0, okay, the second row, first element, how to make in terms of 0 here with the help of the first row, first element form. Okay, now 91, okay, minus 91 of R1 element here. Likewise, R3 dash, R3 minus, okay, now the 2 into the R1, R4 dash, R4 minus 3 into the R1, R5 dash, R5 minus, now 4 into the R1 here. Now what about the next one? We can specify in terms of, okay, now what about your S? Okay, we can denote 0. Next, okay, now R2, 92 minus 91 into the R1. Okay, now what about your S? Now we can specify in terms of the particularly the 92 minus 91 means here 1. 93 minus 91 means here 2. Now 94 minus 91 means here 3. Next one 4. Now the next elements, now you can check, now we can specify in terms of, because here 2 minus 2 into the 1 here 0, now the same similar elements here, now we can specify. Next 3 minus 3 into the 1, because here 3 into the R1 here, now that's why here now we can consider in terms of all the elements 0 form. Now the last row also now we can denote in terms of the 0 form. Okay, now what about here is, now check all of you, now in such a way that now the after applying the row transformation we get the final matrix A. Now you just check is in the echelon form here. Okay, now what about here, leading entry 1, all the column elements below the leading entry 0, now we can take in terms of, if any 0 rows available, as 3 0 rows available, it should come below the non-zero rows, as 2 non-zero rows available. Now we can consider in terms of the echelon form, the 3 points are applicable for the matrix A. That's why here now we can conclude, now we can find out the rank of the matrix A is equal to the 2 here, because here 2 non-zero rows available, now we can find out the 2. Okay, is it clear all of you? Okay, the important observation, these type of higher the elements available, okay, in the matrices, okay, in the matrix, now we can find out the rank of the matrix in such a way that the one particular procedure wise now apply the row transformation, now finally we can find out the rank of the matrix A. Okay, now that will be the important observation here. Okay, is it clear? Okay, next example here. Okay, find the rank of the following. Okay, the matrix A is given. Okay, the first observation, first you have to check whether the given matrix is in the form of echelon form. Okay, is not in the form of echelon form. Okay, it can be represented in terms of echelon form. Now the next one is, okay, now we can apply the row transformation. Next, okay, now the first observation here is 0 available. Try to make the particularly the first element in terms of the unit element, the 1 form. Okay, now we can easily specify R1 and R2, okay, the row 1, row 2 interchange. Now what about the changes here? Okay, now what about it is, okay, we can denote in terms of R1, R2, the interchange form is the remaining 2 rows, the common elements, the same you can specify. Next one. Okay, next observation, now we can apply the row transformation in such a way that, okay, the particularly is first row no changes, same as it is, now we can write down. Now what about the next second row, now we can specify in terms of, okay, second row first element already in terms of 0 here, no, need not to require to apply the transformation. Next we can apply, okay, now R3 dash changes, R3 minus 3 into the R1. Okay, here row 3 available. How to make in terms of the 3 in terms of 0 here? Now we can apply the transformation. Now the next one, R4 1 available, R4 dash changes, R4 minus R1. Okay, with the help of these two transformation, the elements now we can specify. Okay, row 2 no transformation, that's why here the common elements, the same now we can specify. Now the next one, row 3 here, as row 3 first element obviously 0, okay, because of here 3 minus 3 into the 1 here 0 with the help of the transformation. Right, now the next one is, now we can denote in terms of row 3 minus 3 into the R1 element 0 available 1. Right, now the next one here 0 available, 0 minus 3 into the R1 element 1 available minus 3. Right, now the next one 2. Right, 2 minus, okay, now 3 into the 1 available, now the minus 1 now we can specify. Now the next one, now we can denote in terms of the last row, the fourth row, okay, R4 dash, R4 minus R1, okay, here 0, right. Now the next one, 1 minus, okay, R4 minus R1 here, 1 minus 0 means here 1. Now the next one, minus 2. Next minus 1, now we can denote in terms of, okay, now minus 2, minus of the particularly 1 is nothing but minus 1 here, okay, now minus 3 here, okay, now the next one 0 available, now we can denote in terms of 0 minus 1 here, now we can denote minus 1. Now the next transformation, now we can consider in terms of, okay, now you have to check for the next observation as leading entry 1, all the column elements below the leading entry is 0 here, right. Next we have to apply the some transformation in such a way that, okay, we can easily specify here, okay, keeping first row elements same, second row elements also same. Now we can apply the row 3 along with the row 4, the elements for the transformation here. Okay, now what about here is R3 dash R3 minus R2, R4 dash R4 minus R2 here. Okay, now what about here, now next one, now we can specify R4 minus R2 means here, now elements here, now we can easily take 1 minus 1, 0, minus 3, minus of minus 3 means here is 0 here, now next one also 0. Now the next elements also the 0 here because of the row transformation. Now the common elements available similar, one positive, one negative, now we can denote in terms of the 0 form here. Now finally now we can specify in terms of after the row transformation, now we can denote in terms of here. Okay, now what about here is, now you have to check for the particularly the corresponding the elements in terms of the echelon form or not here. Okay, now what about here S now is in the echelon form. Okay, leading entry 1, all the column elements below the leading entry 0 here. S, now if any 0 rows available, it should come under the non-zero rows here, S the right. Okay, now we can denote the next in such a way that the rank of the matrix A, the 2 non-zero rows available, that's why here now we can consider in terms of the 2 here. Okay, here one of the important observation in such a way that to find out the rank of the matrix with the help of the echelon form of the matrix, otherwise the row reduced echelon form of a matrix, now we can find out the rank of the matrix. Okay, that will be the important thing here. Okay, is it clear all of you? Okay, thank you for watching the video.